episode of the BJ's Physics Classroom. Today, we are going to deal with another question on electrostatics. This question was sent in a long time ago. I dealt with one of it. This is another one. Because I have questions on other topics, I decided to go and deal with those topics those questions before I come to this one. So, the question is on electrostatics, and this is how the question goes. So we read the question, and it reads: two identical spheres of mass 2.0 grams are fastened to the ends of a 0.6 meter long flexible insulating fishing line. The fishing line is suspended by a hook off the ceiling at its exact center. The spheres are each given an identical electric charge. Identical electric charge, that is very important. They are in the static equilibrium with an angle of 30 degrees between the strange halves as shown. So the diagram will come, don't worry. Calculate the magnitude of the charge on each sphere. So this is the diagram that the question is talking about. So the entire length of the rope is 0.6 meters. So when you divide it by 2, you get 0.3 meters. The angle between them, that is as a result of the proportion, is 30 degrees. So let's begin solving the question. Now, let us consider a situation whereby there is no repulsion between the charges. So the charge spheres are in straight line like this, or they are suspended by means of the string like this. What that means is that the tension in the string will be equal to the mg. Parallel forces have equal magnitude. So the tension in the string would have been equal to mg. But in our situation, the two charges are being separated apart by a force, which is the repulsive force between the two charges. So there are tensions in the string. The tensions in the string are provided by the weight of the spheres and the repulsive force between them. So we are going to use the concept of vectors to solve this question. So we need a right angle triangle. So let us consider one half of this big triangle. So because the angle is 30 degrees, half of it will give us 15. Now the tension is provided by this mg and the force of repulsion between the two of them. So when we resolve this tension, we'll get two components of the tension, Ty and the Tx. The F is producing Tx for the T, and the mg is producing the Ty for the T. That is the interpretation of this question. So both Ty and Tx make up T, but Ty is produced by mg and Tx is produced by F. So both F and mg are producing the T. So when we pick that triangle out, we get something like this. We apply the trig ratios to this diagram. Then we get Tx is equal to T sine theta, and Ty is equal to T cos theta. When you apply the trig ratios, sine theta equals opposite of hypotenuse and those kind of stuff. If you have done vectors in first year, you will understand what I'm talking about. So what we do is that we consider the vertical forces in equilibrium. Vertical forces Ty and mg, they are parallel, and parallel forces are equal. So Ty is equal to mg. But remember that Ty is T cos theta, so we get T cos theta is equal to mg. Let's make T the subject in this equation. That will give us mg over cos theta. Take note of this equation 1. I will use it in the upcoming slide. So T is equal to mg over cos theta. Let's call it equation 1. Then we consider the horizontal forces that are also in equilibrium. That Tx is producing the F for that matter. We get F is equal to tx, and that is equal to t sine theta. F is equal to tx. This f is equal to tx, but the tx is equal to t sine theta. So we then say that f is equal to tx, that is equal to t sine theta. Good. So we substitute equation 1, which was mg over cos theta, into this equation. That what that means, anywhere we see t, we put mg over cos theta. Then that will give us this equation. But you know that sine theta over cos theta is equal to tan theta. So f is equal to mg tan theta. When we put in the values that are given to us, we get the repulsive force between the two charges. F to be equal to 0.00536 newtons. That force is very important. Remember, we are going to use the Coulomb's law. We are going to use the electrostatic force. F is equal to K, Q1, Q2 over D squared, where D is the distance between the charges. For that matter, we need to calculate for the distance between the two charges. So we bring our diagram again. The distance between the two charges, let's call it D. To be able to solve it, we still have to consider 1/2 of this big triangle. So when we consider 1/2 of this big triangle, let the distance from here to here become x. Of course, we have the y component of the triangle too, but we don't need it, so we don't use it. The angle between them is 15 degrees. We are going to solve for x. We will multiply x by 2. That will give us d. From here to here, 2 will be x. Multiply by 2, that will give us d. So when we solve for the value of x, applying the trig ratios, we are going to get x is equal to 0.3 sine 15. So the x will give us this value. Then when we use it to find d, which is 2 times x, that will give us d is equal to 0.115 meters. 0.115 meters. Then we apply the Coulomb's law. We have our distance, we have our force, so we can now apply the Coulomb's law. So when we apply the Coulomb's law, F is equal to K squared over D squared. Why K squared? The two charge spheres are identical. You remember I highlighted it in the question. Two charge spheres are identical. Identical charge spheres have the same quantity of charge. So Q times Q, that will give us Q squared, times K, Coulomb's constant, all over D squared. Now we have all the values of this, so we make Q the subject, which is the quantity of charge that we are looking for. We make Q the subject, we get this equation, we put in the values, then what we saw, finally we get Q is equal to 1.19 times 10 raised to the power -7 coulombs. The coulomb didn't come, so please add it. Thank you very much. This is how we go through this question too. I hope that you enjoyed this one. Please subscribe to the channel and share the video so that our other colleagues that are around will also get it on social media. Please do that for me. Thank you very much. I hope to see you again in another video where I'll be treating some of the other questions that have come in. I want to finish with the questions that have come in, then I can then pick topics and then deal with them. Thank you. Bye-bye.